All right. I think we're good. The last stream, my power went out. Something electrical exploded outside. So, I don't even know if the work we did got saved. I think it did, but we'll see. Haven't had a chance to work on it since then, so we're going to, where were we? Where, I guess we should, this, and then, I think we were here. First, let's just go the actual thing. Then we're gonna need to make this. Yes, nice. Okay. So just make sure that this thing is working, huh? Hopefully we have our thing saved. There we go. And then, so this is just gonna, this is gonna be with the one we're using. So hopefully this doesn't run into errors. Let me see how far we can get today. TV weight. Okay, what is that? It's in neuralstyle.py. Yep, that's the main one. Neuralstyle. It's just no add TV weight. So it's saying we don't have this. And that, yeah, I remember that is sort of where we left off. I don't know what TV weight is though, so we'll see. Optimization options. Okay. Okay, gotta get warmed up here. What is that? EX mode? What is that? Okay. TV weight. What is TV weight? Like a flat screen type thing? E to the -3. Pretty standard. Is that like a, it's like their learning rate? That's what it looks like. Try again. TV loss not defined. Here, TV loss. Okay. How far did we get? Like a bookmark. Did that, right? This. Okay, yeah, we did more than I thought. That's good. So, set up the network, insert style and content loss modules. do a deep copy. So copy.deep copy of the CNN, content losses, style losses, TV losses. Okay. Next content index, next style index, initializing those. Net, so just an empty sequential network initialized. And CR column row. Params.tv weight. So need that. Params.tv weight greater than 0. And it initialized to 1 e to the minus 3. Okay, so let's go from here. So TV loss params.tv weight as type, dtype from the setup of our hardware. And we're going to add the module. Give it this number. So the length of the network as a string. That makes so much more sense than when I saw it last stream. Because this is just going to be where we're at in because it's the length of the network. So should be 0 to begin with. And then, so I guess our first thing is going to be the TV loss. Let's see. And then we append the module to TV lost to the list. Okay, well, where is this? This. Okay, all the way at the bottom. So, class TV loss module def init self strength. So initializing it and giving it a new strength attribute. Self.strength, and then we initialize that to whatever the input is. Okay, so initialization is done. Forward pass with the input, which makes sense. So xdiff is input what? So this is going to be batch channel height width. So it's the input height starting from one row down, I guess. Then I guess you can just directly subtract these as long as the dimensions match up. And then subtracting one from the bottom. So it's like we're shifting everything once. I don't know what this is. And then this is a similar thing, but with the width. Right. Right. Okay. So the strength. And then we're going to add up the absolute value of the differences. The differences. X diff plus. I don't know why they're adding it up separately. Can you say absolute and then add it all together? And that's the same as distributing the strength to each. Maybe it's for computation or something. Assume this is what they're going for, right? Yeah. So I don't know what TV loss is, but I know what we just typed in, I think. Basically shaving the top and bottom off, shaving the top off of one, the bottom off the other, and subtracting them. I don't know what, and scaling it by some strength number. I don't know what that would actually do though. Let's see. That was not in the demo at all. So maybe this will do something neat. Let's find out. Maybe save. Okay. I really need a bookmark or something. Here. Go here. Okay, so we're giving it the weight. This is the 1 to the e minus 3. Or 1e to the minus 3. 1e minus 3. Right. So let's go back to what we were here. This looks right. So if it's that, we do the loss, which returns what we just said. It's basically a number. But if we can differentiate over that, maybe that's why they're doing it this way, so they can take the derivative more easily. That doesn't make sense. Let's see. Past it. Here. Okay, so let's see if we can't do this. There we go. That's better. For I layer enumerate list n 1. What does the 1 do? Is that like a number to start from? Just want the documentation. Oh, there's a dark mode now. Cool. I just did it with this extension. I just want the documentation. Enumerate. Thank you. Yeah, that's the start. Okay, that's what I thought. So start from 1. I guess maybe length starts from 1. Not sure about that though. Should be, but okay, so if next content index less than or equal to length content layers or the next style index less than or equal to the length style layers, then the next content index is less than the length of the content layers, or the next style index is less than the number of style layers. So if we either don't have enough content or we don't have enough style, so this loop's gonna happen a lot, is instance layer in com2d. So if it's com2d, and add a stir that's layer. The layer list C for CPU, is that, no, it's capitalized. In content layers, print setting up content layer. Layer list. See. So this is a print. So we're setting up the content layer. Of this and this. Oh, C is not CPU. C is the content list that we provided. Loss module. Okay. I don't think we have this one yet. Content weight. Rams dot normalize gradients. Content weight. And then normalize gradients. Oh. Well, we're gonna have to go through and make that then. So let's just do this one and then go back to that. Okay. But then we're gonna add the module stir length net. The loss module. Content losses. Okay. So we're comparing our list of content layers, I think, to our content layers list and our style layers list, and then we're just conditioning into them. So this is going to be the same thing as this. So this is going to be style. Loss module, so style loss. So we're going to do both of these in a second. So the style weight, and then again, normalize gradients. And we're probably going to need to go add those to the parameters so that they at least have a default. Sterling, yeah, and then this is the same trick to add a module with the proper number because we're building it from scratch. Not sure how the transfer learning is going to work then, though. Style losses dot append. And then after all of that, we increment our C, which is our column. Still don't know what C and R stand for. Anyways, we should go look at content loss and style loss, and then probably these parameters. Let's look at the parameters first, because that's the thing I'm going to forget the easiest. We might already have some. We don't have the weights, and we don't have normalized gradients. Okay, that's fine. So normalized weights, normalized gradients. Okay, so we need these three. More parameters. Oh, actually, okay. Content weight. It's gonna be float. The default's equal to 5. Okay. And then style weight. Again, with type as float. Defaults. 1E2. So that's 100. 100 to 5. What a strange ratio. Anyways. Parser.add argument normalize gradients. And then again, we're going to store true. I don't know what store true does. Let's see. Oh. Action and store true, store false. Okay. So that's like setting it to true or false. Cool. Nice. Okay, so now we need to go to content loss. Here. Define an in module to compute content loss. What? Where are we? Okay, so it's content loss, style loss, gram matrix, TV loss. Okay, so let's do this one. content loss. Strength. Normalize. Okay. Content loss. Init. Crit. What is crit? Strength. So strength is going to be the same thing as strength for TV loss. So mean squared error. So this is just always mean squared error. Why is it called crit? When it's like criteria? Mode is none. I don't know what mode would be. Okay, and then normalize, which is a new parameter we're giving it. We're setting to normalize. Where is normalizing coming from? Anyways, so that's the initialization. Forward. Self input. Self.mode. Loss. Loss equals self crit. Self.target. So the criteria is the input by the target. Makes sense. And if self.normalize loss equals scale gradients apply loss dot self dot or comma self dot target dot strength. Okay, cool. So on the forward pass, so that's what the mode is. So the mode is initialized to none, but if the mode is loss, then we take the loss and normalize if it's set to normalize. We already did that, though. We scale gradients, which is probably another function we need to look at. And then we're applying the strength to the loss. Loss times self.strength. So we're either applying it to the gradients or applying it directly to the loss. That's interesting. Self.mode. Capture. Detached. Turn input. Did we actually do anything to the input? Why are we returning the input? Well, I guess we're just like passing it through. That makes sense. We're just doing a quick pit stop to store some losses. That makes sense. So what is scale gradients? Let's just drill all the way down on content loss. Okay. So this is right above it. So what this is, scale, gradients, and backward. Nice. Okay. And that's why it was set to mode equals loss. Mode is loss. Or normalize. I guess you don't really need to scale the gradients if you're just doing forward passes. How does that get to the backward pass though? Let's see. Static method. Scale. I want to try to get this to the point where I can write it from scratch, you know, from my own perspective. So gotta see what all this stuff is. Autograd function. So we're inheriting from autograd function. And we're taking static method. What is that? So we're inputting a tensor. Dot strength. The tensor. So let's see, what is static method? We're just like quickly stopping by here to swap the strength value. And then we're just like passing the input tensor through. I don't know what static method does though. Grad input equals grad output dot clone. Grad input equals grad input over torch dot norm. Keep dim. Yeah, so there's a whole bunch of stuff I need to look up here. Strength. We're scoring it by the input. First of all, what is static method? I guess we should probably be doing this in a private browser, huh? Could just put that in, whatever. Oh, it's so bright. How do we? Yes. Thank you. Don't need extension. What is this? Define static method using @static decorator. Static method decorator. It's a built-in decorator that defines a static method in the class in Python. A static method doesn't receive any reference argument, whether it is called by an instance of a class or by the class itself. What? Declares a static method in the class. Cannot have CLS or self parameter. Cannot access the class attributes or instance attributes. Class name dot method name. Can return an object of the class. Okay. I think I see. Oh man, it's so much nicer it not being super bright. So let's see. So this, wait, this takes self. What the heck? Anyways, this is gonna let you call forward. Grab function. So what is torch.norm? I just want to see what keep dim does. Keep dim. Whether the output tensors have dim related or not. It's not super helpful. I guess I'm lacking some prerequisite information. Anyways, I guess that's that. Not sure I'd be able to do that on my own. Pretty sure I wouldn't. But we're gonna keep moving. Style loss. Okay. Fine. In module. Compute style loss. Makes sense. Style loss. So we need to initialize self string. Super style loss self. So many selves. And then initialize that. And then so target. It's just a tensor. Guess it's just the initialization. String equals string. Then the gram matrix. And the criteria, I guess. So we haven't defined gram matrix yet, I think. Squared error loss. Node is none. Blend. Weight. None. Normalize is normalize. Forward. So G is going to be the gram. The input. I need to look up a lot more about gram matrices and like why they work, because that's not really intuitive to me. In elements, if self node capture. We're in capture mode. Dividing it by the number of elements. It's like scaling it. If we're in capture mode, in the blend weight, it's none. Self.target self.g.detach. If the number of elements is 0, target self.g.detach applies self.blend weight. Self.target equals self.target add self.blend weight. We're in capture mode, right? We do, so if blend weight is none, we detach. And that's the target. In elements is 0, we detach, then multiply by the blend weight. And then, barring all of that, we sum the blend weight with the detached. If here we're multiplying it here, so if we're in capture mode and there's not 0 or none, we're going to add the blend weight with the detached gram. Then, at Iliad. So else if self.mode loss equals self.itself g self.target. Normalize loss equals scale gradients. Apply loss strength. Return the input. For the forward pass, we're doing the gram on the input, dividing it by the number of elements in the input, doing the capture stuff. But if it's in loss mode, so is loss mode the backward pass? I think so. I think that makes sense. Calculate the losses, which makes sense as part of the backward pass. Then we normalize by applying the scale gradients, which we defined, and self.loss is equal to the scale of loss. So that part is pretty similar to the content loss here, where if we're in loss mode, take the loss, and then, well, we don't have the if normalize, but we take the loss, scale it, and then we scale it. I guess we do. We do have the normalized part. I'm an idiot. So if we want to normalize, we do scale gradients. Otherwise, we just do a straight scalar. Okay. Now, I think we can go all the way back to the top where we started. You know. Where did we stop? Here. And this is the layers, I guess. So we're giving it the style weight and the normalized gradients, which is set to true. So then this is the weight, which they call strength, and this is normalized, which is here. That makes sense. Okay, I was confused about that. That's good. Anyways, back to where we were. I think we've gone full circle. So I think we're here. Yeah. So that was all for conv2d layers. So if layer list are in the ReLU list, no, doing that all wrong. Is instance layer, so if it's a ReLU, if the layer is a ReLU layer, an instance of the ReLU layer, we're going to add at this point this layer. Because we're feeding in the layer from the enumeration starting at 1. Okay. And then let's just see if we can square this up. Okay. If layer list are, this is what I was trying to do before. In content layers. Print. Okay. So this is going to be pretty similar to this one. Except this is going to be, so setting up content layer, layer list, okay. So the loss module is the content loss grams, content weight grams, normalized gradients. Makes sense. And then we add module. it's a Rayleigh, we add the module. And then if it's in the content layers, we're going to add another one. That's the loss module. Content losses dot append loss module. Next content index increment. Okay. And then this is going to be the same thing. Except this style, right? This is going to be style. This is going to be style. This is also going to be style. Makes sense. And then we increment the Rayleigh list number. Okay. And then we do a much smaller one for the max boolean. So we're going to do max boolean or average boolean. Do this. Okay, so that was all within the enumeration of the CNN. Gotcha. Okay, so let's just do this last one and then it should be able to run. If, well, we'll double check and make sure we didn't miss anything. We might have missed something. So if multi-device set up multi-device net. Okay, well, we're gonna have to define that too. Let's just start from the top here. Did we miss anything? Got content loss, got style loss. It's the same definition there and there. These are part of NN. Okay, I don't think so. Just need to do, we need to define setup multi-device. So right before pre-process. Cool. So what is this? Set up multi-device net. GPU split. This one very soon. So this is if we have like multiple GPUs, I guess. So if the length of the split -1 equals the length rams dot multi-device and everything's okay. Okay, so multi-device strategy dot split. So these have to be the same. Otherwise, the inputs, the parameters are wrong. We're going to do one of these handy disclaimers. Number of multi-device strategy layer indices -1 must be equal to the number of GPU devices. Yep. So I do have more than one GPU, so maybe that comes up. Okay. And this is also part of it. So the new net model parallel. Oh no. We've just opened a whole can of worms here. I think we're going to have to define that. Man, that little unassuming lines of code was unassuming. Turning a new net. Do we have, so first of all, let's get these model parameters. So we have GPU multi-device strategy. GPU, that one we probably have. Yeah. Excuse me. Multi-device strategy here. Parser. Add argument. Multi-device strategy. The default. What? 4729? What the heck? That is not what I was expecting at all. 4729. What does that even mean? Anyways, I think those are the. I don't know what that means, but I think those were the parameters we were missing. Okay. So now we need to set up model parallel, which is in Cafe Loader. Did we already do this? I think we might have already done this, which is bad because I should remember. What's happening? Okay. Got very confused. Let's see. Model parallel. Okay, we did. Cool. So what are we missing? Parallel. Gotcha. Okay, so here. So this should not have errors. So let's see what errors it has. So we're ending up here. Okay. Cool. Let's try it. Oh, sort of add argument. What did I do? Oh. Whoops. So far, so good. We did miss something. We missed the gram matrix. I noted that we should go back and do that too. Where is it? This guy. We're missing this guy. Okay. They're making a whole class out of it. Okay. Gram matrix. Module. Def forward. Self input. ECHW. Batch channel height width input dot size. So x flat. Okay, this is the shortest instance of this function I've seen. It's interesting that everything's being done in the forward. Like class inherit module, define forward, and then that's where you put your function. And it returns a matrix. So batch channel height width is equal to the size, and then it flattened is it as C and then height width. So sort of ignored the batch size. Then we're going to do a matrix multiply of itself, its flattened self, with its flattened self's transpose. Okay. So let's see what's still wrong. Hey, look at that. Look at that. We've set up some layers, ladies and gentlemen. Layer 30. Content layer 23. Okay, cool. Let's go back to main. Where are we? Should really remember the line number. Like I could have just remembered 157. Anyways. Here. It's not quite the same line number for some reason, but that's okay. So capture content targets. In content losses. So we're switching to capture mode. Ooh, what is print torch? Hold up for a second and see what this is. So for in content losses, mode equals capture. But then we're exiting the loop. What? And then what is print torch? Print like Lua or torch 7. What does that mean? Type of scale gradients. Print like Lua. Man, I should really learn Lua, I guess. Torch 7. So print torch net multi-device. If multi-device turn. So ignore it if it's multi-device. Otherwise, simple list. But layer enumerate net 1. Simple list. Simple list. This plus stir. So we're like manually wrapping this. Simple list number points to something. Thanks, Kathleen. I appreciate a person that appreciates a good coffee bar. You're a mod? Let me see. Yeah, you're a mod. Nice. Please no yelling in chat. Thank you. I'm going to be taking a break in 20 minutes. But So there's a new line. Okay. So printing sequential. So we're just like trying to print the, I guess, torch print. We're trying to print what the model looks like. Strip. X dot replace. This. Okay. A lot of formatting. No, one or no? No. That's a one. It's got a little dip. Okay. Oof. Not done yet. But what is this part doing? So if it's multi-device, skip the whole function. Otherwise, instantiate a simple list. And then for I layer enumerate start from one. So this is the network, the network trick thing again, where we start from one instead of zero. And then we take that simple list and we add, so we're concatenating the number and an arrow, and then we're printing an insequential of the input and then the simple list. Yeah, so we're iterating through our layers to get the simple list. And then we're going to print it and go input, all the layers, output. So before we do the next part, we're defining strip and in. Strip will replace prints or comma spaces with commas, parentheses with nothing. And then concat a comma. And then in, we'll do the parenthesis with the number in it, plus then concat the in and the string L. What is L? Where is L? Not sure what that is. And then split parentheses with one, and then do the first one. Okay, that function I'm a little fuzzier on. We'll see. See what's next, I guess. So here, IL enumerates net one. So the net trick again, you initiate, you enumerate from one. And then if 2D and stir kernel size stride padding strip. Yeah, so this is one that's going to replace a bunch of stuff. If 2D and stir. I don't know if this is best practice at all, or if this is even close to the right way to do it, but the guy's thing worked. Assume it's a guy at the end of the day, so I gotta start somewhere. Okay, so we're just doing the strip on all of those things, the stride, the padding, the kernel size. And if that was just 2D, I don't know, I feel like these would be the same thing. If conv 2D and stir L channel equals stir L dot in channels. Channels print n. I guess n has to be part of this loop. It's not very functional, but it works. So we're going to replace commas with x plus kernel size. I'm pretty lost. I'm gonna be real with you. And this is the stride. Like this is one of those things where you try over and over again, you get it right, and then it just is what it is in the code. Okay. So that was conv. Oh, okay, I see. So if 2D is in it, you go to conv 2D or pool 2D, and then these are separate ifs. That's what I was missing. I thought this was over here, and then I got confused. Pool 2D and stir L stir equals st dot replace plus replace all those with all of these. And then hitting the in again, so just like the other one. Pretty similar to the other one, but actually, did I do the other one wrong? I did. In plus this plus channel. Oh man, what have we done? So it should be like this. This is what you get for not knowing what you're doing. Oh man, this is very different. Okay. Okay, I start to replace that. What is I doing? Oh my goodness. Okay. You can't tell I'm starting to need a break. So that was really sloppy. Okay, I think it's back. I think it's back though. Let's move on to this one. If it comes out weird, we'll know why. We'll maybe know why. So then this one, kernel size times. Okay, so now we do the x concat kernel size 1. So is the one just like a do this once type thing? Like the first one? Don't replace all of them. Okay, and then else print in okay. I think that works. I definitely did that wrong somewhere in there, but we'll see. So now where were we? Where were we? Not there. Man, I should really remember. Oh yeah, 157. I remembered that, but that's not where we are now. We are, what the heck? Did we miss something? Yeah, so if multi-device capturing content targets. Oh yeah, print torch, net multi-device. So you need multi-device to not be true. I splashed my glasses. Whoops. Content image. Content losses. Content losses, I mode. For style. Okay. So capture content targets and capture style targets. I mode equals none. Okay, so we're basically here. And that stuff should all work. So let's try it and then see. No. Ooh, what'd I do? Man, I should have checked it before I went all the way back to this stuff. It's this one. I'm missing a plus. Here. Duh. Again. name ch not defined. Well, it printed a bunch of stuff. CH not defined. I missed a line. Oh, you know what I did? This. I knew I messed a bunch of stuff up in there. Channels. So yeah, so CH is channels into channel out. Okay, this looks like it worked. This is just a warning. And then this is it printing properly? Whoa, look at that. That's nice. Oh, this is what the X's are for. Look at that. It's a big model. Cool. All right, well, I'm going to take a quick break. I'll be back in 10 minutes. But yeah, I obviously need it because I was fading out. But yeah, I'll be back in a little bit. This. Ooh. Actually, I wonder if I can set up my little... Probably can't see him from there. Dang it. Oh well. Back to this. All right, we are back. Nice. Realized I should probably make these things a little bigger. I don't know. How do I make? I don't know if there's an easy way to just make this bigger. I don't think so. Oh, there we go. That's bigger. Um, how did I do that? I don't even know what I just did. Oh no. How do I undo it? How do I go the other way? Minus isn't working. Oh no. What have I done? Well. Oh no. Let's see. Here's hoping that it doesn't open like that. I guess I should do. Nice. I don't know how to make it smaller, but I guess that works. I guess I'm not gonna make it bigger then. Anyways. Let's see, where were we? Got the number again. I forgot to remember the number. That's all the way down. Here. Capture style. Capture style targets. Okay, here we go. Here we go. Back into it. Image enumerate style images. Okay. Print capturing style target. Stir I +1. For J and style losses, J dot mode. This. 1 second. Okay. J mode equals capture. Capturing style target. This one for J in style losses, J mode equals capture. J dot blend weights style blend weights. Net style images cafe. Okay, so we're just running the net now. I guess we're running it up here too. This is content losses. And this is style. And then got it. Okay, better at that. Okay. So all loss modules to loss mode. We're just like, I thought it did this. I thought it automatically changed to the loss mode. I guess that's wrong. On the backwards pass, I mean. Okay. Maybe normalize content in style weights. Maybe it's content style weights of grams. Okay, so this one we don't have initialized, I think. And we don't have this function built either. So let's do that. We go to params.normalize weights. Here. Why is... Oh well. Okay, it's here. What is it? Normalize weights. And we store true in the action. Got it. And then we need to find, not you, this one. There you go. Right above scale gradients. What's happening? Okay. Okay. So divide it's by channel size. Normalize weights, content losses, style. NIN enumerate content losses. Strength equals I dot strength max I dot target size. Okay. So the strength could be 1, but we're scaling it initially because we're going to scale it anyway. And then it's by the max of the target size. Depending on which image we're in. But I don't know that we would need to do that for content images. Maybe if we're doing a batch or something. Yes. Strength max target size. Gotcha. Okay, now what? So what is this doing? I think we just talked about what it's doing. You have to give it both this content losses and the style losses though. I guess it doesn't have anything to do with the picture, right? Divide weights by channel size. Oh, that makes sense. Like if it's 3, you want it to be split 3 ways. Gotcha. Let's keep going. Where do we stop? We gotta remember to bookmark. Okay, here. So if normalize weights, we did action store true. Then we normalize all the weights. So freeze the network in order to prevent unnecessary gradient calculations. Param in net parameters. Param dot requires grad. Okay. So in all the network parameters, we're turning off the gradients because we don't need to calculate the gradients on the parameters. We're just doing the transfer learning, and then we're calculating the gradients on the pixels of the input image. Remember that. Okay. If params, let's see, then equal to 0. This is just setting the seed. Seed params.seed torch.CUDA manual seed params.seed torch.backbands CUDA and deterministic is true. Okay. Torch.backends.c in deterministic equals true. Manual seed. Ram seed. Okay. Rams in it random. Batch channel height width. Tint. Image dot size. Torch dot rand and channel height width. And squeeze. 0.type. Type. So what is that doing? So we're setting the seed, and then if init is random, content image dot size times 0.001 unsqueeze. So that's just setting noise, and then we're scaling it down for some reason. Else if rams dot init image. Why is it init and then init image? Image if so if params dot init image is none. If it is image. Oh no, I see. I did this wrong. I got confused. I was asking the right questions though, so that's good. If params init image is not none. Image, so anything but none. So even if you put like false or something. Got it. My eyes are swimming. Okay. Clone. We clone the initial and set it as the image. Else the image is content. So if it's not none. Oh, I see. So we can initiate the image to be a different image. That's interesting. I don't know if that would be anything helpful though. Huh. Otherwise, it's the content image. Cloning it. Nice. I don't think we missed any functions there. Okay. Image. Go to nn.parameter image. What does that do? Kind of tensor is considered to be a module parameter. Very important property, a very special property. They're assigned as model attributes. They are automatically added to the list of parameters and will appear in parameters iterator. Assigning a tensor doesn't have such an effect. It's because one might want to cache some temporary state, like last hidden state of the RNN in a model. If there's no such class as parameter, these temporaries would get registered too. Don't think I fully understood that example, but that's okay. I think the puzzle is starting to come together, you know? Let's see. What is next? Some more definitions. And here are the steps. Okay, so where are these being called? Maybe, okay, so let's just skip the definitions for now. And go straight to the meat. So, I think once we've got all of that set, we're going to do num alls. Initially, let's do a list with 0. Set function to evaluate loss and gradient. Run the net forward and backward. Get the gradient and sum of losses. Loss. No. LBFGS internally handles iteration. This function LBFGS. Still don't know what that is really. Internally handles iteration and calls this function many times. So we manually count the number of iterations. Handle printing, saving. And saving intermediate results. Okay. Function to evaluate loss and gradient. This is feeble. What the heck? We run the net forward and backward to get the gradient and sum up losses from the loss modules. Optim.lbfgs internally handles iteration and calls this function many times, so we manually count the number of iterations to handle printing and saving intermediate results. Okay, so this is what? Optimizer loop val setup optimizer over the image. Then we do our while loop. Num calls 0. That's not a list, that's we're indexing into an array. So that's in the loop value. Just how many times we'll do it. Optimize. We use our optimizer to take a step over this football function, which I don't know what that is. Let's see if that's a real thing. Used to evaluate the output of a function by using the arguments passed inside a single. What? Is Faval just the name of a function that takes a single argument? Is that what? Strange. Okay, so the thing we're missing is setup optimizer. When are we going to need this for all function though? You know? But we are going to need a setup optimizer, which is here. So let's do that first, I guess. We'll always be able to see what's failing. So we configure the optimizer. Setup optimizer image. So if the optimizer is LBFGS, I don't know exactly what that is. Prints running optimization with LBFGS optim states. Max bidder num iterations tolerance change tolerance grad. Okay. Hey, man. Maybe these depend on knowing what this is. Not sure. Okay. Wait. Skipped ahead. So if params.lbfgs num correction is not 100 optim state history size .lbfgs num correction optim state. Okay, what just happened? So, if the number correction, LBFGS num correction, not 100, it's pretty specific. Optim state history size, LBF num correction, and the optimizer, the image dereference to the optimizer state, optim state. Wow. Oh, okay. This is hard. Okay. And by hard, I mean I don't understand what's going on. Optimizer equals Atom. We're gonna use Atom. Yes, running optimization with Atom. Optimizer optim.atom add fam. Rams dot learning reads. File params dot num iterations. This one. Turn root file. So if it's Atom, we run it with Atom over the image and the learning rate, which is our parameter learning rate. And then loop file is we decrement the number of iterations. Let's set up optimizer. I guess we decrement it so that we can loop through. Yeah, because loop val needs to be different. It's 1 for LBFGS, and then n-1 for Atom. Knowing LBFGS would help me understand why, though, so I'm gonna have to look that up later. More detail. But first, we're missing a whole bunch of parameters. We need learning rate. We need this thing, correction. We need num iterations. We need optimizer. Okay, let's see if I can remember even half of those. Whoa, what's happening? So let's see. Num iterations. Oh, wait, okay. Num iterations. So it needs to be an int. It defaults to 1,000. We're gonna need. We have a knit. So we have a knit image here. We need a knit. What the? Okay. Okay, this is going somewhere, I promise. So num iterations, and then we need a knit image, optimizer, TV weight should be up here. Okay, I'm just trying to get the list to match. Start with this. Init has some choices, which is cool. It can be random, or it can be image. Defaults to random, which is interesting. I don't know if you'd have to default to random. Unless you just like didn't give it a content image, but then it wouldn't work anyway. So I don't know. Here, optimizer, choices, LBFGS, Atom, Okay. And then what? Learning rate? This should be up here. Yeah, we did this twice. What am I doing? So what's after optimizer? Learning rate? So the learning rate is 1. Wow, that's a powerful default. Oh, maybe that's why. Really bad at them. Okay. Then OBFGS. Not none. Correction. Default equals 100. Okay. I think that was it. We'll have to see. We will have to see. So, num calls, optimizer. Oh, did we not set the actual optimizer? Num iterations. I think we missed the actual optimizer. Got the learning rate. Learning rate specifically for, it's a generic learning rate. It's not for all optimizers. I mean, it is for all optimizers, but it's going to be for all optimizers. That's the problem. Okay. So let's see. And then, so after we call this, we're going to call step football. So let's first check that optimizer. Make sure we had that. Otherwise, this isn't going to work. So optimizer, this. Yeah, I don't think we set that. Oh, we did. Okay. Man, there's a key for going back to where you just were. I need to learn that. So here, so we got this football function, which I guess is just any function that takes one string input, but takes no inputs. What? It's just a function that just runs. Okay, I don't know. I don't know, but let's see. So this is where most of the work is going to get done, I guess. All right, it's going to call the stuff that does the work at least. So num calls. This equals 1. Optimizer dot 0 grad. Init image loss equals 0. Oh, so this is just the basic knowing that, right? We're iterating number of calls. We're zeroing the gradients. We're running the neural network. And then we're resetting the loss. Nice. Mod in content losses. Loss plus equals mod loss dot 2. How do people like bootstrap projects like this up? Like, you just start with something that I don't even know. I don't even know how you do it. Like, I have to be so iterative. I don't know how someone would just start from a blank screen and do this. Especially with so many in-between steps before you see a positive feedback. There's got to be a way to do it though. For mod and content losses, for mod and style losses, move it to the backward device. We have a backward device. TV weights. Like, how am I even supposed to Google that? You know? So, if params for TV weight, alright, so if the TV weight is positive, go to the mods and the TV losses, and then add loss up to backward device. We're adding the losses to the device. And then, oh, maybe backward device is just part of pytorch. And it's the thing that holds the gradients and stuff for the backward pass. That would be cool. Maybe save. Calls. Maybe. Oops. So let's look that up, I guess. What is TV loss? Total variation loss. This is TensorFlow. Okay, but like, what is it? The sum of the absolute differences for neighboring pixel values in the input images. Adding total variation loss to the training loss removes the rough texture of the image, and the resultant image looks much smoother. Whoa. Let's check it out. Let's check this thing out. Yeah, it's really bright. This looks sweet. Image generated using baseline architecture on the left, using separate convolution resize trick. These look the same to me. Is that the point? Is that they look the same? What? Where is One thing that makes deep learning notoriously hard is to search for optimal hyperparameters, and the style transfer. Style transfer involves various hyperparameters, like which content layers to use for calculating content loss, which style layers to use for calculating style loss, content weight, constant to multiply with content loss, style weight, TV weight, constant to multiply with the total variation loss. So making output images smoother. So total variation loss is the sum of the absolute differences for neighboring pixel values in the input images. This measures how much noise is in the image. As shown in experiment 10, adding total variation loss to the training loss removes the rough texture of the image. This will make it looks much smoother. Oh, this is the one I wanted to go to. Heck, man. Now I gotta read this. I'll look at that later. It's gonna be the same guy, I'm sure. (2017). This is a cool image to do it with. Let's see. This is a big. Wait, this is experiment 10. Why am I looking at these other ones? Okay. Train using different values of total variation loss. I wanted to see what difference total variation loss makes in the generated image. For that, I decided to use VGG19 with content layer conv22, style layer conv31. 0 total variation loss. Next TV weight set to 200. Yeah. Oh wow, this is sweet. It really smooths out the image. Look at this. You can see like some of the stuff around the sun and the clouds. That's really nice. I like that. Okay, cool. Total variation loss helps to remove rough texture of the generated image, as can be observed in the two above images, one with the other without total variation loss. The image with non-total variation loss is smooth. Man, people are so good at this stuff. It's crazy. Anyways, let's wait. What the heck? Where did oh, I'm in full mode. Duh. I was very confused for a second. Let's see. Oh yeah, what is backward device? Now we've gone down that rabbit hole. Is that how it's spelled? Yeah, backward device. Is this a real thing or no? Oh, I guess not. I guess not. What is this? Okay. Anyways. Where were we? Did that. We are missing these functions, so let's just keep moving, I guess. Maybe save. Was that up here? Yes. So, right above this, are we still in a... This is all in main. Okay, that makes sense. Maybe save. Where? Here. Maybe save T? There's T. Oh, save iter. 0 and T mod params dot save 0. Okay, so that's like a boolean. Should save equals should save or T. Wait, wouldn't that just be the same thing? Or no iterations? Oh, so if should save is false. And T equals no iterations. Ah, I see. So you will eventually save something. It's like a weird, it's like a cleaner way to set a default, I guess, for this. If should save output file name, file extension, os.path.split extension, brands.output image, put image, images. Okay. And then if T is params.num iterations, file name is output file name. Extension. Output file name. What's Otherwise, it's output file name underscore t. Oh, so if it's the maximum number of iterations. So if you don't say set a save interval, it will just save the last one. I'll have to look at the save iter parameter. But this is going to be file extension. So this is what adds the number to it, basically. Which is cool. It's a nice handy thing. Disp process. Oh, I guess I didn't do this one, huh? Clone. Maybe. So. Maybe perform post processing for color dependent style transfer. So if params dot original colors, this is very important. This, because having original colors is nice. It makes it look like the actual style instead of just mashing two images together. Deprocess content image.clone. Lisp. Deprocess content image. Okay, so original colors is a function we're going to need. This, man, I feel like we're so close, but we're not. Okay. So we need to set save iter as a parameter. Yeah. So save iter. This. Do I not have output options? Parser.add arguments. Print iter, save iter, output image. I do need output image. I was wondering about that, actually. Type int default equals 100. And then this, okay, output image default equals png. Okay, that works. What next? We need to go back down to this function we had. Maybe save. Original colors, what is that? And deprocess, gotta do that too. Maybe save. Okay, let's do inside first. Deprocess. Preprocess, deprocess. And then there's original colors right there. Nice. Okay. Undo the above preprocess. If deprocess. Output. Insert. Normalize. Transforms. Compose. Transforms. Normalize. The mean. Standard deviation, I'm assuming. And that's going to be these numbers. Correct. Okay. Nice. Glad that worked. Okay. That's that. Close the list. Close the compose. On to the next. BGR to RGB. Why does it have to be compose all the time? Lambda X switch on tensor. I don't think there's anything in there's, oh yeah, it's 210, which is just the reverse of this one. But it's funny because doing the reverse is doing it the same after it's been reversed. It's doing the same reversal on the reversed. And you've got this amount of containment. Okay. Nice. Scrolling sucks. Okay. Here we go. Output tensor equals BGR to RGB. Normalize. Output tensor squeeze 0 CPU. Okay, so we're moving it to the CPU. Output tensor squeezed to the CPU. Normalized by the first compose. Oh, so if you normalize by the opposite of the values, then it works. That's interesting. I hadn't thought about that. Okay. Output tensor. Clamp. Oh, clamp in place. So image to pillow. Image to pillow. Okay. So this is going to make it like a regular picture again. Right. Insert CPU. Turn image. So we're making a normalize type, a BGR to RGB type, and then we're chaining the normalize, dividing by 255, sort squeezing it onto the CPU, and then going from BGR to RGB, which we went from RGB to BGR the first time. And then we're clamping it so that it doesn't get crazy, I guess. And then we change it back into a pillow image. This could technically be up here, I think. But that's okay. And then the image is this to the CPU. I feel like it would already be on the CPU, but oh well. Okay. So what we need next then is going to be the original colors. So combine the Y generated image and the UV CB CR. The generated image in the UV CB CR. No idea what that is. Channels of the content image to perform color independent style transfer. UV CBR CB CR. Yeah, I don't know what that means. Let's see what the function looks like. Original colors, content generated. Content channels list content converts YCB CR split and generated channels. Converts CBCR split. Can we just do that? We're doing it for each. Combining the Y with the generated and the UVCBR. Let's get content channels. Generated channels. So we're setting the Y channel of the generated. Setting the Y channel of the content to the Y channel of the generated. Is it this easy? What? I mean, it's not easy, but merge Y CBCR content channels converts RGB. What? Image merge. But the image is not in this function. There's no image. Just implied. Just imply that you're returning an image to it, I guess. Oh no, I hope that didn't just ruin everything. What? What? Maybe save. Deprocess. Okay, cool. Well, let's just go back before we messed up more. Alright, we got maybe save. I need maybe print. Let's see. Did I go too far? Yeah, so deprocess original colors. Dang it, where was... Not that one. Yeah, so when you say, so it does it when it saves it, not when you're doing the style transfer or anything. Huh. That's interesting. So maybe save. Let's do maybe print. Maybe print. And loss. Okay. Params dot print. See. I think we just did this. It's close. Print hitter or 0. Like pinch hitter. Print hitter, print iteration 30 plus iteration this brands dot num iterations. That makes sense. And then for I loss enumerate. This guy loves to enumerate. And I don't blame him. You can enumerate so many things. Okay. It's a bunch of prints. So if print iter is greater than 0 and t mod print iter is 0. So if we're going to do it and we're at it, then we do it. Content I plus 1. Oh, because we're just starting from 0. Okay. Loss modulo loss. And I wish I could scroll horizontally. Loss dot item. Grr. Right, that's really annoying. Come on. Come on. Okay. Oh, lost module, lost item. I lost module. Enumerate. Style. Losses. 8. Style. I guess it's this. So we've got different content losses, style losses. Okay. Plus 1. Loss. Plus third. Module. Wait, we just did that one. Let me focus up. Okay. Stir. Yeah, so it's just the same thing but with style. That's why I got confused. Lost module dot loss dot item. So you do this because the style loss will have multiple, whereas the content loss will have usually one. So it'll be like style, 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 content. Or content, style, style, style. Let me do it this way. Total loss. This. No. Plus there. Loss that item. Okay, so that should print it all. Let's just see what we're missing. Parameters. What? Oh, I just typed that in wrong. 189. Yes. So we're going to be missing parameters. Sure about that. Sure about that. Namespace object has no attribute seed. What? So that's probably just the parameter. Let's go to seed. Yes, other options. No. Okay. So here. Nice. Seed. Int. -1. Interesting. Try again. Has no attribute num iteration. Okay. What? Num iterations. Okay. Line 215. Nice. I didn't put the S. Look at that. Fixed it so quick. Above near him. Okay. There's no attribute print iter. Right. The old pinch hitter. Print iter. Other options. This one. Reset this. Nice. Alt equals 50. Let's try it. try it again. It's running. Duh. Name transformed is not defined. Should be transforms. 342. It's freaking S's. Try it. Did I give it the LB FGS? Or is that part of pytorch? Original colors. I knew I was missing a bunch of these. There we go. Other. No. Okay, other options. Style scale. What? Original colors. Int choices are 0 or 1. Defaults is that you will not have your original colors. One more time. Maybe. Maybe. So what is it doing? It's running the... Okay, it's doing a forward and a backward now. That's a good sign. This is just the total loss, so it's not even... I guess you can see the other losses there. Why is style 4 always so big? Style loss on 4. Hey. Whoa. We did it. We did it. We copied the guy's thing. And it works. That's sick. Man. I like it. I'm a fan. Oof. That's so much. So much code. I don't even know how I would do that by myself. If I'm ever that good at this. Man. People are so smart. Blows me away. Anyways, I'm going to use some version of that as the thumbnail, and then we're going to play around with this a lot, I think, on Friday. Have some fun with it, if we can. See if we can make something cool. But for today, I am tired, so we're going to spend the last 5 minutes working on this thumbnail, and then I'm going to head out. So let's see. Why did that look not great? Because we even did this for 300 instead of more. Anything else I want to do? Yes. Let's run this one first, I think. Make sure it works. I want to see where... So I thought that... I don't remember where we set this up. Is it just an optimizer in... Developed on LBFGS. Okay. This is what I want to see. I'm inspired by Minfunk. Yeah, I don't know what this optimizer is doing. Let's see if there's like a blog post or something. What is this? How do you use LBFGS instead of stochastic gradient descent? Okay. This one's not too old. I'll read this later too. I never look at these things that I put off, but hey, it's there. Nice. Why does that look the same? That looks the same. Did we actually do something? What's happening? Yeah, no, these were all just made. Let's see. Why is it like crazy right here? And then just like the regular picture over here. Are we? What's going on? Style image, content image, blend, style blend. That's weird. I wonder what happens if I do like something like this. Yeah, that's what I thought. Let's see, what were some of the other parameters we could set? I mean, I feel like it shouldn't even have to have the... Yeah, so I guess it does have to have this. Or is it just this? I feel like it shouldn't have to have the weights equal 1. Unless, like, you should only have to blend weights if there's 2 style images. So maybe that was throwing it off somehow. Let's see. This is cool. We're gonna try to do some, I wanna get to the point where I can just like automate the thumbnails for this, you know? So they'll be cool and different every time. It'll probably get boring, but I don't care. It's my channel. Sometimes you can do things just because they're your baby, you know? Even though I spent like a fraction of the time on this than this guy did. Ooh, wait, okay. So our loss is still going down. Right? Yes. We haven't exploded or anything. Could probably run this for a long time. Look at this. Yeah, it's doing the thing every time. How weird. How weird is that? Anyways, I think you guys get the idea. I'm gonna keep messing around with this, but off stream, you'll see the results on the thumbnail. But until Friday, hope you have a good one. See you then.